Hi dear students, I am just going to explain chapter number 9 of the book of Dr. Joseph Hare, and this is the book named as Multivariate Data Analysis 8th edition, and it's by Joseph F. Hare. And I am going to just describe you people about the chapter number 9, that is of structure equational modeling. And in this lecture I will describe all the basics of structure equational modeling and how we can test our measurement and structural model in this lecture. So first of all, I just want to describe about the main components of this chapter, and after completing this lecture and this chapter you will be able to understand the distinction characteristics of structural equational analysis, and secondly you will be able to distinguish between variables and constructs, and you will be able to understand structural equation modeling and how it can be thought of as a combination of familiar multivariate techniques. The other thing you will be able to explain is you will be able to know the basic conditions for causality and how SEM can help establish a causal or cause and effect relationships. The other thing you will be able to explain the types of relationships involved in SEM, and you will also be able to understand that the objective of SEM is to explain covariance and determine the fit of a theoretical model. Moreover, you will be able to know how to represent a SEM model visually with a path diagram, and you will learn and list the 6 stages of structural equational modeling and understand the role of theory in the process. So first of all, when we talk about the structural equational modeling, it's abbreviated as SEM and pronounced as SEM. So SEM or SEM is a family of statistical models that seek to explain relationships among multiple variables. That is a very simple understanding of SEM. That is a statistical technique which is used to explain the relationships among the variables. Now the things which differentiate SEM from other statistical methods: SEM examines the structure of interrelationship expressed in a series of equations. Moreover, SEM enables researchers to address a multivariate and indeed multi-equation research problem with a single analysis. So in this way, SEM is distinct from other statistical models that it can simultaneously analyze multiple equations in a single analysis. Furthermore, SEM involves both interdependence and dependence techniques. For example, when you are going to analyze certain data in terms of factor analysis, SEM can do that, and if you are going to analyze regression, so SEM can do it alone as well as combined with the factor analysis. So SEM involves both interdependence and dependence techniques, and in this way multiple equations represent the theoretical structure. Now keep it in mind that SEM analyze all the relationships based on certain theory. So theory determines what things are connected, and just as importantly, theory determines what things are not concerned. So SEM relationships are built based on theory, and this technique of analyzing the data just confirm that either your theory is fitting your model or not. So the other thing, SEM combines two multivariate procedure into one. Now keep it in mind, the SEM analyze your data based on two models or based on two techniques. First of all, SEM can analyze your data in terms of factor analysis. So first of all, SEM can, these factor analysis models are known as measurement models or measurement theory. Basically, in this measurement models, SEM connect latent constructs and the measured variables. This is phenomena is known as a factor analysis, and in SEM mostly it's known as a confirmatory factor analysis and known as a CFA. So when we talk about the measurement theory or measurement models, so we are going to use a confirmatory factor analysis and it's known as a CFA. The other thing SEM can do is regression analysis, and in SEM we just assess the fit of the model. And these regression analysis, in the development of regression analysis models, the models are known as a structural model, are known as a structured theory. They connect only latent variable to each other. So SEM combines these two multivariate procedures. First of all, SEM use factor analysis and then combine this factor analysis with regression analysis. This is done by developing two models. The first model is known as a measurement model and the second model is known as a structural model. In simple words, SEM is developed based on these two models. First measurement model and the second one is the structural model. Okay. So SEM sometimes called as a analysis of covariance or covariance structure analysis. The other name of SEM is latent variable analysis, or it can be named as causal modeling, and this can be done in Literal, AMOS or EQS. These are the three softwares which can be used to analyze data in terms of structure equation and modeling. Now, what are the distinct characteristics of SEM? And when we talk about the characteristics of SEM, estimation of multiple and interrelated dependence relationships are analyzed in SEM. SEM is an ability to represent unobserved concepts in these relationships and account for measurement error in the estimation process. So it's very important to note that SEM is a technique which has an ability to represent unobserved concepts, and as well as we can judge measurement error in the estimation process. The third characteristic of SEM is we develop a model to explain the entire set of relationships and we analyze all the relationships simultaneously. Okay, here are certain points to note that when we talk about the structural model or when we talk about the structure of the variables, actually structure represent theory. The user specify a structure model that include a limited set of relationships. Thus, SEM is distinct from other multivariate procedures in terms of SEM is not an exploratory analysis, it's a structural analysis, and SEM tests the user theory and does not explore relationships or reveal a model. So SEM provides more accurate estimates of the parameters, and structural equations only include the relationships that are necessary to represent the model according to the theory. All other possible connections are assumed to be zero. So structural equational modeling are contrast with the reduced form equations. When we talk about the reduced form equations, these are the equations which solves for a single endogenous constructs in a single equation with all and only exogenous constructs. So in simple words, we can say that the reduced form of equations are the equations in which only single dependent variable is calculated by certain independent variables, while SEM can calculate multiple independent variables with multiple independent variables. So it is different from the reduced form equations. Now comes to the basic concepts of SEM. There are two types of variables in SEM. First is known as the latent constructs or latent variables. These are the hypothetical, unobserved, unmeasurable concepts that can be represented by observed or measurable variables. While the other type is known as observed variables or the measured variables or manifest variables or the indicators. These are directly assessing some specific aspects or the concepts. Basically, observed variables are the variables on which we collect the data. For example, in psychometrics, the measured variables are individual survey item responses of the individuals, or in big data or secondary or archival data, the data on social media, cell phone usage patterns, or geographic movement. All these data which is directly observed or measured is known as a observed variables, while the hypothetical or unobserved or unmeasured concepts or variables which are represented by observed variables, which are calculated by observed variables, are known as the latent constructs or latent variables. So latent variables are depicted by ellipse or these circle type objects, while the observed variables are depicted by rectangles in the SEM path diagrams. Okay, in SEM, as I have told you, there are two types of variables, as I have told earlier, observed and unobserved variables. There is an other classification of variables. Some are known as exogenous variables and some are known as endogenous variables. In a simple understanding of these exogenous constructs, you can think of these constructs or these variables as independent variables. So we can say that the independent variables are known as exogenous variables. While in the SEM, endogenous constructs can be treated as dependent variables or the variable of primary concerns. So first of all, I just want to describe the characteristics of exogenous constructs or exogenous variables. They use a variate or the linear combination of measures to represent the constructs which act as an independent variable in the model. These are basically the measured or manifest variable represent the exogenous constructs. They are not explained by any other construct or variable in the model. Visually, they do not. Now that is a hint to analyze, to identify the exogenous variables in SEM. They do not have any path or single-headed arrow from any other constructs or variable going into it. And when we talk about the endogenous constructs, these constructs are theoretically determined by certain factors or certain other variables within the model. The dependence is represented visually by a path to an endogenous construct from an exogenous construct. So unobserved or unmeasured represent the endogenous constructs. Visually they do have any path, single-headed arrow from any other construct or variable going into it. It means certain arrow, single-headed arrow are coming from other variables go into in these variables. So when we see any arrow coming from any variable and going towards an other variable, the variable from where the arrow is coming is known as an exogenous construct, and the arrow going into any variable, that variable is known as endogenous construct. Now the other thing is reliability in SEM, how we can judge the reliability. Reliability is basically the measure of the degree to which a set of indicators of a latent construct is internally consistent based on high interrelated indicators are with each other. Reliability represents the extent to which the indicators all measures the same things. So as reliability goes up, the relationship between a construct and indicators are greater, meaning that the construct explain more of the variance in each indicator. So we are concerned with the reliability in SEM. So just we learn in multiple regression, as more of an outcome is explained, in this case a measured indicators of a construct, the amount of error decreases. So errors decrease is the sign of reliability. So in SEM models, when we develop a model and we are talking about the SEM models, these models are basically the representation of the theory. And a theory is a systematic set of relationships providing a consistent and comprehensive explanation of any phenomenon. So when we are using SEM, SEM involves basically two models, and as I have told earlier, the first is measurement model and the second is structural model. And as I have told earlier, that measurement model provide measurement model defining pattern corresponding rules of relationship between measured variables and latent constructs, while the structural models are just linking the latent constructs. So latent constructs are unobserved variables are analyzed by using structural model, while in the measurement model we are just going to analyze the measured variables with the latent constructs. Okay, to understand this concept of measurement model or the structural model, we can see that these are the unobserved variables are the latent variables which are examined by the with the help of observed variables. So this relationship is known as a measurement model. And in this model, this variable is in exogenous because it is influencing the other variable, while that variable in this example, this variable is endogenous because it's influencing the other. So the relationship between latent and measured variable is known as a measurement model. So here you can observe that the measured between the measured and unmeasured constructs. So when we are going to judge or when we are going to model the measured variables with latent variables, we are developing measurement model. And while we are connecting the unobserved variables or the latent constructs, these are known as the structural model. So this is a part of measurement model and this is known as the structural model. So here is another thing which we have to observe, that the dependence relationships are depicted by single head arrow, while the correlational or the covariance relationships are depicted by double head arrow. Now, what is the role of theory in specifying or establishing the relationships? Specification of the both models, as I have told you people that in SEM we use two models. First one is measurement model and second is structural model. Now how we can specify the relationships of different variables, that is solely based on the theory. And theory plays some fundamental roles and in three aspects. First one, by using theory we can specify the relationships that define the model. It's mean we specify the relationship between the latent and measured variables, and after that we have to establish the causation, and the third step, by using theory we can develop a modeling strategy. Now we discuss what are these three things. First of all, the first thing in SEM, we have to specify the relationship between the variables. So that is known as a model specification. model specification we just identify, or we just specify the relationship between the two or more variables. So based on theory we can just build a model that is, it is used for testing and potentially confirming the theory, as I have told earlier. So in this example you can see there are many variables, and when we specify in the path diagram in the relationship of these variables, this phenomena is known as a when we just identify the the variables which are independent and which are dependent, this is basically the model specification. And when we establish a cause and effect relationship between the variables, these are known as a causation relationship, establishing causation. And there, in establishing causation, we have to keep in mind the four things. The first one, we have to see which variables are covariating. What would be the sequence of variables, what are the non-spurious covariations, and fourth one is the theoretical support, what is theory saying. So take this example. For example, there are two variables, supervisor and job satisfaction. We specify that supervisor is a latent and the job satisfaction is also a latent variable, but supervisor is influencing job satisfaction. So in this relationship their effect is effect of supervisor on job satisfaction is 0.50. It's mean when supervisor support or the supervisor is increasing by 1 unit, job satisfaction will increase by 0.50 units. Okay. This is basically the original relationship, and we have specified these two relationships. Now the other thing is related to the non-spurious relationships. When we observe that in the relationships of supervisor and job satisfaction there is another important condition, which is working condition or working environment. And we found that before influencing the supervisor's support on job satisfaction, supervisor's support influence on working conditions, and on working conditions, due to these working conditions, job satisfaction is influenced. So the direct relationship of supervisor and job satisfaction become non-spurious. So to the extent that relationship changes, the supervisor job satisfaction relationship is spurious. So we are just interested, this is a spurious relationship. So we are interested in non-spurious relationship in testing the SEM. The other thing is developing a modeling strategy. There are three strategies, and first one is confirmatory modeling strategy. It's mean when we specify the relationships of variables, we just confirm that this relationship is fitting our model or not. The other thing is, and then we compare models, and then we compare those multiple models, and we find the best model from all those multiple models. The third one is model development strategy. It's mean we initially developed a model based on certain theory, and after based on certain modification indices we can develop our best model. So these three modeling strategies are used, as I have told earlier. Confirmatory modeling strategy, we just develop a single model composed of certain relationships, and then we test either it works or it doesn't. It is just by seeing the acceptable model fit. The other thing, as I have told, is that we have to estimate, we have to compare the estimated model with alternative models, and then we see overall model comparison. It's mean when we develop, first of all we develop a model, and after that we develop multiple other models, and then we develop those different model with each other, and which model is more fitting data, that is used. And the third is, as I have told, that we just develop a model, and after that we modify that model based on certain modifications. Okay, now comes to the visual portrait of the model, and as I have told you that in SEM we just describe the relationship in visual form, and that visual is known as a path diagram. And in the visual portrait of the relationships employ specific methods both for the construct and measured variable as well as the relationship between the two. So first of all, we have to depict the constructs involved in the structural equation model. So first of all, we have to develop the measurement model, and after that we have to develop the structural model. Then we have to combine measurement and structure relationship, and then we have to see how well does the model fit. So you can observe here that this model is known as a measurement model, and this model is known as a structural. This model is basically known as a structural model, because here you can observe that these unobserved and these unobserved constructs and observed constructs are analyzed, and here we are just analyzing the influence of exogenous or the latent construct on another latent construct. So this is the example of a structural model, and that is the example of a measurement model. These two types of models are used in the SEM. And when we talk about any structural model, we just see that this is the analysis of latent constructs, and here you can observe that there are 5 latent constructs, and the arrow depicting the relationships, and from these relationships 7 relationships are specified. These are the 4 causal relationships, and the 3 covariance relationships are specified, and 3 relationships, possible relationships, are not specified. For example, impact of supervision on job search is not specified because it is not supported by the theory. So basically SEM work in certain stages, and these are known as 6 stages of SEM, and the detailed description of these 6 stages are on coming certain slides. For example, when we talk about the first stage, that is defining individual constructs, and when we are going to analyze any variable, we have to define individual constructs, and we have to see the operationalization of all these latent constructs. So we have to identify, or we have to observe the measurement scales and the rating scales and the measurement quality and the harmony of measurement. So in doing that, I just want to describe all these 6 stages with the help of certain example, and the database which is described in the Joseph Hare book, and this is the data set with the name of hbat_scm. This file is being used in this video, and the variables in this file are the following, and from here you can observe that this is the employee identification number, and the other variable is age, experience, and the another variable which are AC1, 2, 3. These 4 variables are these 4 measured variables are observed variables are AC1, 2, 3, 4. And these 4 items, these 4 variables are basically the items in the survey, and the wording of these items or questions are in front of you, and these 4 questions are asked for attitudes towards coworker. These 4 questions are asked to judge the construct of attitudes towards coworker. Now The other thing we have to see, that was the operationalization of a latent construct. It's mean we observed that in judging the AC1, in judging the attitudes towards coworker, there were 4 questions in the survey. The other thing I have described you, that we have to see the measurement scale and the rating scale. Now comes on the scale, and here we see that there is a 5-point Likert scale, and this measurement scale is scale. It is a metric data. So all these 4 variables are measured on. This is another form of Likert scale, that is from 1 to 7, and this question is asked is having a scale of 1, rating scale of 1 to 5, and having different anchors for measuring this variable. And the 4th question of AC4 is based on an other metric scale, that is 1 and 6. So we just observe the data of these variables, and when we see the data, we can see here that this is the metric data having values ranges, different value ranges, but on certain metric scales. So now we have a problem of different rating scales. So there are certain variables having different scales. When we are facing this problem, we will use the standardized estimates. So at this stage we have to just observe the operationalization of the constructs, and second one, we have to see the measurement scale, we have to see the rating scales, and the measurement quality, harmony of measurement. So in the first stage we have specify all these things. Now comes to the stage number 2, and here we have to develop and specify the measurement model. Now in specifying the measurement model, we have to specify these 3 things. First of all, we have to specify the measurement relationships. So when we are going to analyze all these things, we have to analyze these variables in AMOS. So I'm just opening a file that was having a variable without label, because here are the variables with labels, and these labels will create problems in the path diagram of of AMOS. So I have created another file without label. So I'm just opening that file with the name of hbat_scm. So I am just using that file. So I'm closing the file with labels. Okay, now when we are going to specify the measurement model, I am just going to open this file with IBM SPSS AMOS. So I just click on IBM SPSS AMOS, and here are certain files which were already used in that. And now I am just going to develop another new file in the AMOS graphics. So I'm just opening a file with new file. Okay, it's a new file in AMOS, and as I have told you people that I'm going to use the hbat_scm in that. So in the first step I have to select the data file. So just click on this icon, select data file, or you can select it by going into file and here from data file. There are 2 options in selecting the data file. So when you click on it, you have to select the file name, and you have to specify the file from here. It's hbat_scm file, and I'm opening it. When I select this file and click OK, this file is included in the AMOS program. So the other thing we have to now we have to develop three things. We have to first of all develop the measurement relationships. Now I'm going to develop the measurement relationships. So first of all, I just see the variable list in the data file, and from here you can see that there are certain variables, and I have told you people that AC1, AC2, AC3, AC4, these are the four items, are the four questions in measurement of attitudes towards coworker. So first of all, I have to develop a measurement model, and for developing the measurement model you have to select this icon and just click there, and then click on this ellipse. There are four questions, so you have to click 4 times 1, 3, 1, 2, 3 and 4. Now these are the four indicators of a latent variable, and now I am just going to change the shape of this, and I am just rotating the indicator of this latent variable. Now I'm just going to add the measured variables in the rectangles. These are four measured variables: AC1, AC2 and AC3 and AC4. All these are for the attitudes towards coworker. So I am just mentioning a name attitudes towards coworker as A to C. So this is the specification of measurement model. The other thing I have to develop it, okay, correlational relationships. So there are certain other measurement models. For example, here is another variable, that is environmental perception, and having 4 questions. So I'm just developing another measurement model having 4 questions. So in doing this, I'm just adding these variables in it: EP1, EP2 and EP3 and EP4. These are the 4 variables measuring the these are the 4 variables which are to measure the construct of environmental perception. So it's environmental perception. So this construct of environmental perception is measured by these 4 observed variables, and I have specified these 2 measurement models. So the other thing in specification of the model, you have to develop the correlational relationships. Okay, now I am just describing the correlationship of these among these 2 variables. The other thing you have to do is the measurement errors for these. So these are the measurement errors. These are the measurement errors, and we have to give the names to these measurement errors. So there is a plugin in AMOS, and you can name unobserved variables, and by just clicking on it, AMOS will automatically give the names to these measurement errors. So we have developed a measurement model, and we have developed and specified the measurement model. Moreover, in doing that, I have another variable, and that is organizational commitment, and having 4 questions. So I am just drawing this measurement model of organizational commitment having 4 items, and this is OC1, this is OC2, this is OC3, and this is OC4, and these are different models, and I am just rotating it, and now I am giving the name of this variable, just give it to any name, and its name is organizational commitment. So I just give the name to this, and after that I have to give the name to the unobserved variables. These error terms are named, and now I have to develop the correlation among with other variables. So this is the correlation among other variables. So I can make a clean diagram by clicking on the magic clean, and here we can do the things. Okay, now this is the first step in the SEM, and I have developed and specify a measurement model. Now it comes to the third stage, and that is designing a study to produce empirical results. So when we are discussing the study in terms of empirical results, I have to describe the few points or few considerations. There are main two considerations in designing a study to produce empirical results. First of all, you have to see the data in terms of the measurement. Either your data is metric or non-metric data. The second thing you have to analyze is the sample size. The third thing is covariance, or you are going towards correlations. And the fourth important thing is missing data. In terms of missing data, you have to analyze the extent of missing data and the patterns of missing data. Then you can judge the impact and remedies in terms of missing data. And in dealing the missing data, I'm skipping this topic in detail because this topic of missing data has been covered in chapter number 2 of this book, examination of data. And here you have to just see either you are going to use complete case approach, all available approach, or model based approach. The in estimation, for example, you can use maximum likelihood, expectation maximization approach, or multiple imputation approach in terms of dealing with missing data. So the details of dealing with missing data is represented in chapter number 2 of this book. So first of all, we are interested in types of data, sample size, covariance, missing data. And in the second consideration, we have to see the estimation. We have to look at the model structure. Then we have to select any software, and then we have to select any estimation techniques. When we are talking about the model structure, we have to see possible parameters, and we have to see which parameter is free and which is fixed. Then we have to select any software. Either we are going to use Literal, AMOS, or M+. The third thing, we have to decide the estimation techniques, and there are certain other techniques mentioned here, and most of the time we use maximum likelihood. Now see all these considerations one by one. In research design, first of all, we see the data. Our data is basically metric data. Now comes to the sample size. How much sample size is required for SEM? This is a very difficult question to answer, and when we talk about the sample size, it's dependent upon these 4 to 5 things. First of all, your sample size is based on your multivariate normality of the data and generally accepted ratio to minimize problems with deviation. If your data is deviating from multivariate normality, then you have to see the ratio of deviation and the ratio of respondent for each parameter estimated in the model. If you are, for example, if you are going to estimate 2 parameters, then you should have 30 respondents. If you are going to estimate 4 parameters, then your data sample size should be at least 60 respondents. It means 15 respondents for each parameter estimated in the model. The other is related to the estimation techniques. If you are going to use the maximum likelihood estimation, the sample size should be between 100 to 400. The third thing is based on the model complexity. If your model having more constructs that require more parameters to estimate it and constructs having less than 3 indicator variables, or you have a model having multiple groups, then your sample size requirement vary based on the model complexity. If you are estimating more constructs and having more variables, then you are required to collect data from more respondents. The other thing is the amount of missing data. If your data is missing, then you are required to use a larger number of respondents. The fifth thing is average variance, average error variance among the reflective indicators. For example, when we talk about the commonalities of the factors, models containing multiple constructs with commonalities less than 0.5, the standardized loading estimates less than 0.7, these then you are required to use the larger size for convergence and model stability. Now the other thing, either you are going to calculate correlations or covariances in designing the SEM. The other point here, you observe that in the research design and are designing the study, you have to decide either you are going to use covariances or correlations. Now see what is the difference between the correlation and the covariances. Correlation is basically these are the estimates. Now first of all, just I just want to describe you people about the a correlation and covariance. Correlation or covariance are basically the association of two or more variables. These are the measures who describe the association of two variables, that is known as a correlation. And if we are interested in the variability of two variables, that is known as a covariances. So correlations are the standardized estimates, and these measures are not scale dependent. Their range of estimates are from -1 to +1. And identification of inappropriate estimates are easier than with covariances, and the correlation lead to error in standard error computations, while the covariance is a measure of the joint variability of two random variables. These estimates are not standardized, have no defined ranges, provide more flexibility due to the relative greater information content they contain. And in the statistical point of view, the hypothesis concern questions related to the scale or magnitude of the value, then we should use covariances. So in designing the study, you have to decide whether you are going to use correlation or covariances. These are certain advantages and disadvantages of using different missing data procedures, and I am skipping here because it has been covered in chapter number 2. There are certain rules related to the SEM in stage 1 to 3, and now when you are done with your model, when you are done with your research design, and this research design can be decided from here in analysis properties. So go to the analysis properties, and as I have told you people that you have to decide about the estimation technique, and I have told you people that is based on the maximum likelihood. Now this part is related to the missing values. If your data is having certain missing values, then you should tick or select estimate means and intercepts. It's mean when you are going to in this method, by selecting this option, you will calculate the means of the estimates for the missing values. So the other purpose of your computing fit is that you find the fit and you are going to fit the saturated and independence models. The other thing you are interested in is the factor score weights. Now here you have to decide whether you are going to use covariances or correlations, or you are interested in both things. Now scared multiple correlations and standardized estimates, and the other thing we are going to select is nothing. Okay, we can select test for normality as well, but now I'm just interested in all these things. The decision about all these things, if your data is not normal, and you can use bootstraps or other options are as well, but I'm just going to describe you the initials of SEM, so I'm just selecting few options. So this is the third stage of SEM, and I am done with selecting or designing the research strategy. Now comes to the stage number 4, that is model validity. Now comes here and just put on just click on calculate estimates. When you click on estimates, the AMOS will ask you to save your path diagram, and when you click on the save, and then it will analyze your path diagram. First of all, you can see the model summary from here, and here you can see that the chi-square value and degree of freedom is mentioned here. You can see that chi-square is 89.6 and degree of freedom is 51. Now I will tell you the details of these statistics in the output menu, but here some basic points I want to describe you people. First of all, you have to click on the output path diagram. This is by clicking here you will get certain values on your path diagram, and these values are for example, when we are interested in the values, I just describe you which value is for what purpose. For example, this is your construct of organizational commitment, and this is your first indicator of organizational commitment, and this indicator having loading the score of 1 because this was fixed. This is 1.27, this is having score of 0.79, and this is the score of 1.16. These are the intercept of this regression. This is 4.89 and this is 8.42, and this is the variance of this error term, and this is 4.13, this is 1.15, 1.70, 1.23. These are the variance of error term. This is the intercept of this regression, and this is the basically this is the coefficient of this indicator and this construct. So these are the unstandardized estimates. This is the covariance, this is also a covariance, and this is also covariance. So now I just click on the output path diagram and then on the standardized estimates, and from here you will get the standardized loading. These are the standardized loading or standardized coefficients. This is 0.59, this is also known as a factor loading, and this is 0.59, 0.87, 0.67 and 0.84. If you are interested or you should retain those items which are having a high factor loading. This factor OC1 is having less factor loading and is 0.59. There is no hard and fast rule for the factor loading. You can decide it based on your own perception or based on certain modifications which will be described later on. And this is the intercept, standardized intercept, and this is the covariance. This is also a covariance, this is also covariance, and this is the factor loading, and this is the intercept of this regression. Anyhow, these are the certain values of the diagram. So I am just making the better shape for the understanding of the diagram here, and now just here. So even I can make this diagram better by just clicking on the plugin of Magic Clean, and when I am on input method, I just go in plugins and click on Magic Clean, and I will find a better diagram. Okay, now comes to the fourth stage of SEM, and that is related to the measurement model validity. That is a very important point in structural equational modeling. And when we use structural equational modeling, we have to assess the model fit. Its mean between two determined by the correspondence between two matrices. First one is observed covariance matrix and the estimated covariance matrix. Now, what is observed covariance matrix? Observed covariance matrix is simply computed from sample observations, and the estimated covariance matrix are basically composed of the predicted covariance between all indicator variables involved in SEM based on the equations. So the fit measures or the model fit can be judged by comparing to these two matrices. So how we will judge these things? This model validity can be judged by analyzing these two things. First one is goodness of the fit, that this is known as a GOF, goodness of fit, and the second thing is the construct validity. So first of all, I just describe the basics of goodness of fit. When we talk about the goodness of fit of the model, SEM describe these four types of measures related to the goodness of fit. In order to judge the goodness of fit of your model, you have to first of all analyze the chi-square. And in chi-square you have to analyze these three things. First one, you have to analyze chi-square value. Secondly, you have to analyze the degree of freedom, and thirdly, you have to analyze the statistical significance. So you have analyzed this path diagram. Now go to the text, view text option, just click on it, and you will find here the text output. And when you click on the text output, here are certain components of the output, and as I have told you earlier that first of all, this is the analysis summary, this output containing the information and having the two parts, the left side having the hierarchy of the output, and the right side having the analysis properties, are having the analysis estimates. So this, in this navigation tree, first of all you should see the analysis summary, and from here you can see the date and time and the title of your path diagram. Then you have to see the sample size, and then you have to see the variable summary. And in the variable summary there are certain variables in the list. These are the observed and endogenous variables. These all are observed as well as endogenous variables, and these are certain unobserved exogenous variables. These are the list of unobserved and exogenous variables, and here is the statistic related to the number of variables in your model. In your model, total variables were 27. Either from them 12 were observed and 15 were unobserved, and from them exogenous were 15 and endogenous were 12. Now come to the parameter summary. When you talk about the parameter summary, here are fixed 15 fixed parameters, 0 were labeled, 9 estimates were unlabeled, and the total 24 weights were computed, and 3 covariances were computed, and 15 variance were computed, 0 means were computed, 0 intercepts were computed, and in unlabeled there were 12 intercepts were computed, and total 54 parameters are computed in this model. Now comes to the notes for model. As I have told you that the sample size is based on your parameters and your variables in your model. Now just see on the degree of freedom. Number of different distinct sample movements were 90, and the number of distinct parameters were 39. So the difference of this is 51, and this is known as a degree of freedom. So this is the chi-square value, this is the degree of freedom, and this is the probability level. Now see here, we have said that the chi-square value should be smaller, degree of freedom should be higher, and the statistical significance should be larger. Its mean now comes to the output of this, and from here you can observe that chi-square is 89, degree of freedom is 51, and probability is 0.001. In AMOS output, if you are confused with any value, you should just click on it and you will find the help regarding that value. So when I click on the probability level 0.001, it is saying that if the appropriate distribution assumptions are met and if the specified model is correct, then the value of chi-square is the approximate probability of getting a chi-square statistic as larger as the chi-square statistic obtained from the current set of data. If chi-square and its value is 0.05 or less, the departure of the data from the model is significant at 0.05 level. So your data and model is compared, and the difference is, if this difference is significant, it is not required. So your probability should be should be greater than 0.05, but it is dependent on certain other factors. So this is not a valid information, or you just cannot make a decision based on chi-square test. So for just a first step in analyzing the measurement model, you should just see these three things. So we have see the chi-square goodness of fit. Now comes to the absolute fit and the incremental fit and the parsimony fit. When we talk about the absolute fit indices, the chi-square statistic, in chi-square statistic, CMIN divided by degree of freedom, that should be less than 3 or less than 5. If this value is less than 3, it is good, and if it is greater than 3 and less than 5, it is permissible. Now comes on the output, AMOS output, and click on the model fit. This is the absolute goodness of fit in fit measure, and from here you can see it's a CMIN, and in your default model you have to look at the CMIN over degree of freedom, and it is 1.75, and it is less than our yardstick or our standard, that is less than 3. So it's mean our model is a good model. This is in acceptable range. Now comes to the other goodness of fit indices, which are GFI and Ramsea and RMR, SRM, or the normed chi-square, and certain incremental fit indices. Norm fit indices are Tucker-Lewis index here, or comparative fit index, or RNI. All these and their thresholds are mentioned here. For example, GFI should be greater than 0.901. Your TLI or CFI should be near to 1 or above 0.90. And here are certain values of AGFI and PNFI. Your AGFI should be lower than GFI. When we talk about the GFI, these are the GFI value should be greater than AGFI. These are certain yardsticks or certain threshold values for these fit indexes, and you have to see either your model is fitting or not. So instead of observing all these measures, some experts say that these are certain goodness of fit measures which are important. This is from the Hu and Bentler 1999, and from here he is also saying that CMI over degree of freedom should be less than 3. So first of all, just see either our CMI over degree of freedom is less than 3. Yes, it's less than 3. Now comes to the p-value for the model. It should be greater than 0.05. Our p-value for the model is not above 0.05. It's less than 0.05. It's a problematic, but it is permissible in because this chi-square test is not a hard and fast rule to reject or accept any model in the AMOS. The other thing is CFI. CFI should be greater than 0.95, or it should be greater than 0.80 even. So we can see CFI from here in the model fit. This is CFI and it's 0.98. Good, it's very good value and it is acceptable. Now some goodness of fit indices, for example, TLI or RFI, these are above 0.97. IFI, TLI, these are above 0.97. So these are in acceptable ranges, and AGFI should be greater than 0.80 and less than GFIs. So AGFI is not mentioned here. Okay, now comes to the other thing that is related to the Ramsea, and from here just see that Ramsea should be less than 0.05, or it should be in between 0.05 or 0.10. So first of all, we have to see the value of Ramsea, and here is Ramsea. It's the RMCA, pronounced as Ramsea. I'm just pronouncing it. It's not a standard to pronounce it. I'm just pronouncing it Ramsea. So the value of Ramsea, this is the value of Ramsea, and it should be less than it should be less than 0.05. So observe in your output that either it is less than 0.05 or not. It's 0.04. It's mean it is less than 0.05. Now comes to the p close value. Now see the yardstick for p close. P close is should be greater than 0.05. Now see p close is greater than 0.05. So these all are within the ranges. Now either there is any problem or not. Now there are certain other things which should be considered, and the detailed guidelines related to the goodness of fit measures are mentioned here, and this table is taken from the book of multivariate data analysis in the chapter 9. This is the table 9.4. This is the characteristics of different fit indices demonstrated a goodness of fit across different model situations. If you are having sample size which is less than 250, then your indices should be in these ranges. And if your sample is greater than 250, then your indices should be in these ranges. So these are the detailed guidelines for this. Now with these, there are certain guidelines for establishing acceptable and unacceptable fit. First of all, use multiple indices of different types, at least one incremental index and one absolute index. And the third thing is your chi-square value and degree of freedom. All these three things should be considered. And the second, adjust the index cutoff value based on model characteristics. These can be based on these cutoff values, or the threshold values should be based on model characteristics, and I have to show you the table. The third thing is you should compare models whenever possible. So I have observed that our model fit indices are almost within ranges, but the one thing is creating problem, and that is in the nodes group and in the parameter sum nodes for the model. We have observed that the model probability is very low. It should be greater than 0.05. Otherwise, all the model fit indices, CMIN over degree of freedoms, CFI, TLF, TLI, IFI, all these are within ranges because these all are above 0.9. The other thing is P Ramsya, and the Ramsya value is less than 0. Is greater than 0.03, and this the lower and upper bound of the Ramsya is positive, and the P close is also within the ranges. We have observed all these things from here. So we now what should we do? Either our model is best fitting or not. So we should go for certain other alternative models. For example, when we are analyzing this, we should go for three things, as I have told you in the start of this presentation, that we have to specify the relationships, and I have told you that how we can judge or what strategy should be used, as I have told in the early certain slides of this lecture, that there are three strategies in developing a model. First one is confirmatory. As I have done all this, that was confirmatory strategy, and I have confirmed from fit indices that my model is a good model. The other is competing model strategy. You can use competing model strategy. You can use certain other models. For example, you can specify certain other variables. For example, now comes to the AMOS output, and now estimates, click on the estimates, and from here just click on the scalar, and from scalar go to the regression weights. Now see the estimate of different regression weights, and from these are the unstandardized regression weights, and from here you just observe that your p-value is significant or not. All the regression weights are significant. If you are having any insignificant coefficient or insignificant weight, then you should delete that question from your model. But I am having all the regression weights having significant p-value, and the values are within the ranges. This can be better understood by regression weights of standardized regression weights, and from here just see the regression weights are also known as effector loadings. These are the standardized regression weights are known as the are the factor loadings. The factor loadings are good, but one question is having low factor loading and it's 0.592. Now in pursuing the competing model strategy, I'm just going to delete this uh, question, which is having a very low loading, and that is OC1. So I'm just going to delete this OC1 in the path diagram. So I just click on OC1 and clicking on the error as well. So I am now going to analyze this. Now one thing I will describe you, there will come an error. Now see, an error will emerge. This is error which is not computing the signal, which is this is there is an error of model specification, and this when you go for the text output, you will find here that your model is probably unidentified. It's mean what happened to our path diagram. Now this error is because we have not fixed certain parameters. So just click on select and select on one parameter and fix it as 1, because when we developed the measurement model, by default SEM put a regression weight of 1 in a 1 indicator of a construct, but when I deleted in OC1, the factor parameter was also deleted, so all these become free parameters. And now I just fix this parameter again. Now you click on estimate and you will find the solution. Now your chi-square has been calculated, and when you go to the text output, you will find the output. Now from here you can observe that your chi-square value has been declined and your probability level has been increased. And now go to the model fit, and model fit CMIN is decreased and the CFIE is almost getting better. And in going to the RMCI, you have a good value. P close is also in range. So I think I have compared two models, one with OC1 and the other without OC1. Using OC1 I have reached on a better model. So the other strategy is the models development strategy. What is this model development strategy? Model development is just develop a better model by using modification indices. So go to the analysis properties and click on the modification indices, and in just go in the just close it and analyze the. Now it will give an error because this data file is having certain missing values, and the values and the data set having missing values cannot be calculate modification indices. So in doing so, you have to select a file without having missing values. I have another file which is free of missing values, and this is hbat SEM with no missing values, and I click on it and click on OK. Now the file has been selected without missing. Now you can calculate this estimate. Now come to the output. Now what happened? Just go to the modification indices, and from here just to see what happened. He is saying that E10 and E11 and A2C, E11 and environmental perception is If you correlate E11 and environmental perception, your changes will be better by 7.7. No, we cannot do that because E11 is here, and environmental perception is here. No, we theoretically or conceptually these variables cannot be correlated. So we have to just see the statistical inferences as well as conceptual issues. So the other suggestion is connect E10 and A to C. No, we cannot. And now he's saying that E7 and E12 we cannot. He's saying that E7 and E8 are correlated, E5 and 6 are correlated. So we just correlate E7 with E8. So go here and connect E7 with E8. He's saying that do that. Okay, now just click on the analysis, analyze, and you will calculate the estimate and go to the output. Now see what happened. The model probability is improving, chi-square is getting lower, while in the model fit indices CFI is getting lower, TLI is getting lower, CMIN is getting lower, and Ramsey value is within range. Anyhow, the other modification indices should be also be analyzed now. Go to the modification indices, and he is saying that you should connect these indices, but we cannot because they are having different things. He is saying that OC to AC. Okay, now this is our final model because we are using these strategy. First of all, we confirm our model, then we compete our model with other alternative models, and now we develop our model by using modification indices. Now comes to the other things which we have to do, and that was we were on stage 4, and till stage 4 we have confirmed the measurement model. These were the 4 stages, and we have observed our model till 4 stages. Now come to the stage number 5 and stage number 6. Now we have to, in stage number 5 we have to specify structural model, and we have to assess structural model validity. So in doing so, first of all, when we are going to develop the structural model, we have to change the shape of our model. And now I'm just going to click on the paths, and I'm facing a problem of zoom, so I want to zoom it out. Now just delete these covariances and connect these variables in terms of causal relationships. Just draw a variable, an arrow from here to here as well. It's mean now these two constructs A to C, these are unobserved variables. These two constructs become the predictor or exogenous variable for the organizational commitment, and the organizational commitment is now the dependent variable, and these two are the independent variable. When we specify them as dependent and independent, we have to add an error term for the dependent variable, and now we have to give the name to it, and it could be named as E13. Okay, now close it, and now come here in estimation, and in the output click on the indirect, direct and total effects. So just now just a second, I am just put the name in the variance. We have to give the name in the variable name. It should be E13 because E12 was already here. So just save it, and now calculate the estimates, and he is saying that you should covariate among the among the independent variable. So just click on this arrow and add this covariate symbol among these two. So just save it and analyze, calculate the estimates. Estimates has been calculated. Go to the output, and in the output you will find the, now you have find that your chi-square, you have your probability of the model is above 0.05. Now first of all you have to analyze the estimates, because in the structural model your estimates are very important. These are two estimates. These two estimates values first of all can be judged in terms of standard error, critical ratio, and the significance of the model. So this is these two paths are significant. It's mean effect of attitudes towards co-worker on the organizational commitment is significant and 0.309, and the effect of environmental perception on organizational commitment is also significant at 0.68. And the standardized estimates are here. You can see these standardized estimates by just clicking on here, and from here you can see that it's 0.18 and it's 0.46. It's mean we see standardized regression weights to simplify the interpretability of these estimates. And it's 0.18 effect of attitudes towards co-workers 0.188, and is effect 188, and the effect of environmental perception on organizational commitment is 0.469. So we can see that these both are having effect, and it's mean if 1 unit will increase in A to C, there would be 0.18 unit change in organizational commitment, and if 1 unit of environmental perception will increase, there would be increase in organizational commitment as 0.469. So there are certain other things. Now comes to the model fit, and now observe that it's less than 0.3, and CFI is 0.993, 0.91, 0.9, it's within the ranges. And the other thing is Ramsia, and in here it's 0.03, good, and the P close is also within the range. So in this way we are just completed with our structural equational analysis. Now comes here, we have developed structural model fit, structural model, and we just analyze our structural model fit. Now the other thing we have to see is the assessing the structural model validity. Now you should also use some alternative or competing model as well. In terms of structural model, if you are interested in using the alternative or competing model, you should add certain other variables. For example, you can add this variable, this relationship in the but before adding this, you can delete this covariance relation, and you can add one arrow from here to here. And if you are adding some arrow here, you can it's saying that you should add error term in your endogenous variable. Now A to C is become endogenous, and now you should add an error term here, and in the variable name give the name as E14, and now see this model and see the fit indices, see whether they are improved or not. Now go to the SPSS output. The probability level is same as was with the previous model, and now comes to the model fit. and these model fit are as before. So we can see that there is not a, but Ramsia is getting better, and CMI is within the range, CFI is as in the previous model. We can judge the modification indices, and when we see here he is saying that E10 and E14, E1 we cannot do that, and he is saying that regression weight A to C to AOC2, if you put that, that would be better. So we observe that statistically this relationship is not existing. This is not a better option. So we delete it, and now we add arrow from here to here, and we delete this error term because now it's become an exogenous variable. Now add error term in it because it become endogenous variable. So give the name of error term here, and now see what happened. Give it clean and things like that. Now just click on it. Now see what happened. Go to the output and see what happened. Now see the probability of the model is not getting better, and it is the same as was. So these competing model are as same as previous model. So our proposed model was a good model. It's mean the thing we have done in early stage was good. So just this is our final model. Now analyze it and judge the properties of goodness of fit Myers. So go to the output window from here and see this was the best model, having the things as before. So now we are done with our testing of structural equational modeling, and this is the there are certain rule of thumb. You can read it from these slides, and I think you are able to learn the basic of AMOS, as well as you have learned two things. First one related to the measurement model, and the second one is known as the structural model. And in the first stage of your measurement model you test the CFA, and these were the early 4 stages of SEM, and in the last 2 stages you test for the structural equational modeling. Thank you so much.